Hi everybody, I just wanted to remind you if you're watching this before Tuesday, our exam is on Tuesday the 21st, okay? And this material won't be on the exam, it will be on the next exam, okay? So we're going to talk about complex numbers. So first let's talk about what started out complex numbers. Okay, so we define I to be the number so that I squared is -1. Okay, so remember that no real number has the property that when you square it, you get -1. So we had to come up with this other number, I, that does have this property. Okay, so we say that multiples of this number are called imaginary numbers. Okay, so for example, we might have 5i or -2i or I itself. Okay, those are all examples of imaginary numbers. Okay, so now let's get to the topic of this section, which is what is a complex number? Okay, so we have a number of the form a plus bi, where a and b are just regular real numbers. Okay, so some examples of this might be 2 plus 3i, okay, or 5 minus I, okay, or even just something like 2i, or something that is a real number like 7. Okay, now the parts of a complex number have their own names. Okay, so the part here that is just a real number is called the real part. Okay, and then bi, which is a multiple of I, is called the imaginary part, right? Because we said multiples of I are imaginary numbers. So this is the real part because it's a real number. This is the imaginary part because it's an imaginary number. Okay, so let's look at an example. Okay, so we're going to look at the examples that I gave when we looked at the definition. Okay, so these are all the examples I gave of complex numbers. So for each of them, we're going to list the real part and the imaginary part. Okay, so for the first one, this is kind of the most normal example, right? The real part is the real number part, so that's 2. And the imaginary part is this part here with the I, so that's 3i. Okay, the second one is very similar. You can see the real number part is 5. The imaginary number part is -I. Okay, and you do want to include the sign here. Okay, now here you can see there's no real number part, so that means the real part is 0. Okay, and then our imaginary part is 2I. Okay, similarly here, right, we can see that the real part is just number 7, and there's no imaginary part. That means the imaginary part is 0. Okay. All right, now let's talk about how to do some operations with these numbers. Okay, so if you want to add and subtract complex numbers, the main point is you want to combine like terms. Okay, so let's look at an example. Okay. Okay, so we're adding these two together. We're going to add the two real parts because those are like terms. So 11 plus -2 is 9. Okay, and then we're going to add the imaginary parts. -4I plus -8I is -12I. Okay, so you can see you're just adding the coefficients. Okay, all right, let's do another example. Okay, so whenever you're subtracting something with two terms, I always recommend to students that they distribute the negative sign. Okay, and then we're going to combine our like terms again. So we have 2 minus 3 is -1. Okay, and then I minus 7I is -6I. Okay, all right, let's do one more subtraction. Okay, so again, we're going to distribute our negative sign. Okay, and then we're going to combine like terms. So 1 minus 1, that's 0. So the real part of our answer is going to be 0. Okay, and then we have -3I plus 5I. Okay, so that's 2I. All right, so let's look at multiplication. Okay, so the key with multiplication is you want to distribute and combine like terms. Okay, so let's look at an example. Okay, so here we have an imaginary number times a complex number. Okay, so we're going to distribute this 2I. So we have 2I times 3 plus 2I times I. Okay, so 2I times 3 is 6I. Okay, and then 2I times I is 2I squared. Okay, now remember the definition of I, right? I is a number so that I squared is -1. So we're going to replace this I squared with -1. Okay, so I would end up with my answer -2, the real part, plus 6I. Okay, now you can see I changed the order of the terms, and that's because for complex numbers you want the real part in the front and the imaginary part second. Okay, let's look at some more multiplication. Okay, so again we're going to distribute. So 4i times 6 is 24i. 4i times negative 3i is negative 12i squared. Okay, again we're going to replace the I squared with negative 1. Okay, so negative 12 times negative 1, the real part is positive 12. Okay, and then our imaginary part is plus 24i. Okay, so you're really treating this like you would another binomial at the beginning where you're distributing. Okay, let's look at an example of a complex number times a complex number. Okay, so we're going to distribute like you would with any other binomial. So 4 times negative 2, okay, and then 4 times 3i. Okay, then we have negative I times negative 2, okay, and then we have negative I times 3i. Okay, so we're going to multiply these. This is negative 8. This is 12i. This is plus 2i. And this is minus 3i squared. Okay, well remember I squared is negative 1. Okay, so now we're going to combine our like terms. Okay, so we have negative 8 and positive 3. Okay, so that would be negative 5. And then we have 12i and 2i, so 14i. All right, let's do one more of those. Okay, so we're going to multiply it out. 6 times 1 is 6. 6 times I is 6i. 5i times 1 is 5i. And 5i times I is 5i squared. Okay, so now we're going to replace I squared with negative 1. Okay, and we're going to combine our like terms. So 6 and negative 5 is 1. 6 and 5 is 11. Okay. All right. Now we have one more operation to do, which is division, but before we get to that, let's talk about what tools we need to do division. Okay, so for complex numbers, we have what's called the complex conjugate. Okay, so you can see that if this is the original number, the real part is the same, and the imaginary part has the opposite sign. So let's look at some examples. Okay, so you have 2 plus 3i. That was our first example of a complex number. Its complex conjugate is 2 minus 3i. Okay, it's not very hard to find a complex conjugate, but it is useful, and one of those uses we're going to see when we do division. Okay, we might have something else. Okay, so again, the real part stays the same, the complex part opposite sign. Okay, now what if you already have a negative complex part? Well, the real part stays the same, okay, and the imaginary part gets the opposite sign. So if it was already negative, then the complex conjugate has a positive imaginary part. Okay, now here's some trickier ones. If you have just an imaginary number, remember the real part is 0, so the real part of the complex conjugate will still be 0. Imaginary part is 2i, so the imaginary part here is going to be negative 2i. Okay? And then what if you have just a real number? It's its own complex conjugate. Okay, don't see that very much, but I just thought I would point that out. All right, so now let's talk about how we're going to do division. Okay. So this one has a couple more steps. The first thing we're going to do is find the complex conjugate of the denominator. Okay, then we're going to multiply top and bottom. Okay, by that number that we found in step 1. Okay, then you are going to simplify top and bottom. Okay, and then the last thing you want to do is write it in the a plus bi format. Okay, so let's look at an example of this. Okay, so we would look at the denominator and say, what's the complex conjugate of that? So my complex conjugate is positive 3i. So I'm going to multiply in the denominator and the numerator by that complex conjugate. Okay, you want to multiply in the denominator, okay, because you'll see what can happen. And then in the numerator, you just have to make sure that you're multiplying by 1. Okay, so here we'll distribute. So 12 times 3i is 36i, and 3i times 3i is 9i squared. Okay, now in the denominator, negative 3i times positive 3i is negative 9i squared. Okay, and we're going to trade out both of these I squareds for negative 1. Okay, and I'm going to finish simplifying that. All right, so now I have a real number in the bottom. Well, we know how to divide by a real number. Okay, now I want to point out at this stage that this is why you use complex conjugates. When you use a complex conjugate, okay, and you multiply it with its partner, right, these are complex conjugates, you will always end up with a real number. Okay, and that's why you use complex conjugates to divide. Okay, so I'm going to split this up. Okay, 36 divided by 9 is 4. 9 divided by 9 is 1. Okay, and then I'm going to write this in my a plus bi format like that. All right, let's look at another example of this. Okay, So I'm going to multiply numerator and denominator by the complex conjugate. So the complex conjugate here would be 2 plus 5i. Okay, and then I have to do the same thing in the numerator. Okay, now I'm going to multiply these. 5i times 2 is 10i. 5i times 5i is 25i squared. Okay, and then I'm going to multiply out in the denominator. 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2 is negative 10i. Okay, and then negative 5i times 5i is negative 25i squared. Okay. So now I'm going to simplify the numerator and the denominator separately. Okay. So you can see here, right? Well, we'll leave that for another time. Okay, so I've replaced both of my i's with negative ones. Okay, and now I'm going to simplify even more. Okay, so I have 24 plus 25, which is 29. Okay, and then here I have plus 10i and minus 10i. Those are going to cancel out. Okay, and I will remind you again, that's the whole point of complex conjugates. The imaginary part should cancel. You should end up with just a real number. Okay, now this doesn't divide evenly like the other one, but we can certainly still split it up. Okay, and rearrange the terms. All right, let's do one more like that. All right, so we're going to multiply by the complex conjugate of the denominator, which is 2 minus I. Okay, and then we're going to multiply this out. So 10 times 2 is 20. 10 times negative I is negative 10i. 15i times 2 is 30i. Okay, and 15i times negative I is negative 15i squared. Okay, then in the denominator, I have 2 times 2, which is 4. 2 times negative I is negative 2i. I times 2 is positive 2i. Okay, and I times negative I is negative I squared. Okay, now we're going to simplify by changing those i's into negative ones. Oops, that is a negative 1 now. That was the whole point of this step. Okay, right, minus I squared minus negative 1. Okay, and then I'm going to combine my like terms. So I have 20 plus 15 is 35. Okay, I have negative 10i and positive 30i, so that's positive 20i. Okay, and then in the denominator, I have 4 plus 1, which is 5. And again, my imaginary parts are going to cancel out, right? You want them to cancel out. The whole point of this method is that the denominator becomes a real number. Okay, so now I'm going to split it up. Okay, 35 over 5 is 7. 20 over 5 is 4. Okay, and that's my final answer. All right, so I hope you guys enjoyed this intro to complex numbers and learned something about how to do operations with them. I'll see you guys soon.